Let's face it, no one wants an asteroid to kill all life on our planet. Yet despite Hollywood's insistence that we could stop this catastrophe, scientists argue that even a global alliance with billions of dollars at its disposal wouldn't stand a chance against a massive celestial body hurtling toward Earth. So let's imagine that we have exactly 2 weeks until a stadium-sized rock collides with our planet. It will explode with the force of 4,000 Hiroshima atomic bombs. What should we do? Is there any chance we can save ourselves? Or is the end of the world really inevitable? You're about to find out. You wake up in the morning, check your phone and see the breaking news. NASA confirms that there's a massive asteroid heading for Earth. According to rough estimates, its size is comparable to a football field, and the collision with our planet will cause an explosion equivalent to 4,000 atomic bombs dropped on Hiroshima. Scientists say there are only 2 weeks left until the impact. Don't panic, they say, but it's too late. Even if we mobilize all available resources, we won't be able to avoid a catastrophe. So now you've got only 2 options. You can either wait for the end of the world, or try to do something about it. What's the best way to destroy an asteroid? That's what NASA scientists have been thinking about since 1998, when they launched the Near-Earth Asteroid Scout program. It was designed to assess the possibility of deflecting a hazardous asteroid off its course. Although so far the agency has only managed to successfully land on one asteroid named Bennu. But that's another story. In short, scientists believe that the most effective way to destroy an asteroid would be to drill a hole deep enough inside it, and then bury a nuclear bomb in that hole. The energy released by the explosion would be enough to disintegrate the asteroid. But will that work? Well, not necessarily. In 2019, astronomers discovered an asteroid called OK, which was hurtling toward Earth. It was only 1 day before its closest approach to our planet that scientists were able to spot this celestial body, which means there was almost no time to prepare. Then, in 2022, another asteroid, MK, was spotted only 13 days before passing Earth. Both these discoveries prove that there's a good chance we might not notice an asteroid until it's already dangerously close to us. So we may find out about the approaching danger literally 2 weeks before the apocalypse, just like in our story. And will we be ready for that? The answer is no. Even if we manage to drill a hole in an asteroid the size of a football field, that would take many years. But no one said anything about the drilling process being easy. In 2021, NASA tried to land on the asteroid DM1 as part of its Origins, spectral interpretation, resource identification, security regolith explorer, OSIRIS-REx mission. The spacecraft equipped with a drill had to collect samples from the surface of the asteroid. But although the attempt was successful, the sample return failed, and it wasn't the first time. Back in 1998, the Japanese Muses C probe tried to land on the asteroid Itokawa, but it failed, while the British spacecraft Beagle 2 was supposed to land on the asteroid's surface in 2004 as part of the European Space Agency's Rosetta mission. However, during the landing attempt, the probe lost contact with Earth and never landed on the target. The Italian scientist who headed the project admitted that most likely the spacecraft simply fell apart. So perhaps building drills capable of penetrating the surface of an asteroid isn't such an easy task after all. It would be much easier to deliver a powerful explosion onto an asteroid if we could just land spacecraft equipped with nuclear bombs on its surface. But that's also fraught with difficulties. For example, how do you keep a spacecraft stable in microgravity? After all, landing on Earth is hard enough, even in an atmosphere. Moreover, an asteroid isn't just some kind of rock in space. Its gravity is greater than 0, but it's still lower than that of Earth. Under these conditions, centering the explosion right in the middle of the asteroid will be extremely difficult. And if it goes even slightly off-center, the chances are that instead of destroying the asteroid, we'll only manage to make a dent in it. And if the explosion doesn't produce a chain reaction, the asteroid will continue moving toward Earth. So does this mean we're doomed? Not necessarily. Scientists from the Planetary Society think that we shouldn't try to destroy the asteroid, but instead we should simply push it away. They're currently testing the efficacy of this method on the Didymos asteroid system located 7 million miles from Earth. It consists of a large parent asteroid and a small moon that revolves around it. If the test proves successful, we'll know for sure that we can deflect an asteroid off its course. But don't rush to celebrate yet. In 2021, the double asteroid redirection test, DART spacecraft equipped with a 500 kilowatt engine was launched to the Didymos system. It had to crash into the smaller asteroid moon and change its speed by several kilometers per hour. That's because the kinetic impactor technique is based on the principle of conservation of momentum. When the spacecraft hits the asteroid, all of its momentum will be transferred to the celestial body. The moon revolves around the main asteroid once every 11 hours and 55 minutes. And after the impact, this period should increase. But the observations showed no changes. It turned out that the DART spacecraft did manage to alter the asteroid's trajectory by even 75 seconds. But why? It seems like there are actually two possible explanations here. One is that the calculations were wrong. After all, the mass of the moon was overestimated by more than 5 times. As a result, the impact force turned out to be 3 times weaker than expected. But there's another option. Maybe we just don't understand how the universe works. Perhaps there are physical laws unknown to modern science that we have to consider while designing our spacecraft. For now, both theories remain speculation. The next attempt to alter an asteroid's trajectory won't take place until September 26, 2022. This is when the Hera probe will reach the Didymos system and perform a flyby of the moon. Only then will we know whether it was the calculations that were wrong or if there is some other explanation. That means we're still far from creating a planetary defense system, and until we figure out how to effectively remove dangerous asteroids from orbit, our chances of survival are close to zero. How do you feel about that? I personally believe that humankind has always found a way out in similar situations. For example, in 1908, a Nikolayan asteroid, 2 kilometers in diameter, fell over the Tunguska River in Siberia. The explosion force was equivalent to 12 megatons of TNT, which is 300 times higher than the power of the bomb dropped on Hiroshima. And although back then there weren't any satellites or probes to warn us about the impending disaster, people still managed to survive. And who knows? Maybe we'll come up with a brilliant idea on how to deal with an asteroid even sooner than it'll cross paths with our planet. Let's say we'll create a bunch of drones armed with powerful lasers that will erode the rock until the asteroid disintegrates completely. Or maybe we'll build a huge net to catch it. Well, that's unlikely to work. But what if we make it out of graphene? Now forget about it. It won't help. We'll need to design a completely new material that'll combine the strength of graphene, the lightness of aluminum, the heat resistance of tungsten, and most importantly, it'll have to withstand micrometeorites. And given that their speed reaches 72 kilometers per second, that new material will have to be incredibly tough. Yet I'm sure we can handle that. And I suggest we start working on this project right now. So what's the problem? It turns out that designing a material isn't the only thing we'll have to rush through. We'll also need to improve many other technologies. For example, telecommunications. An asteroid the size of a football field will block most radio signals. And if we can't establish communication between the crew members, it'll be impossible to coordinate their actions. Then we'll have to develop spacesuits that'll protect people from radiation and meteorite bombardment. Oh, and don't forget to design a spaceship that'll take us to the asteroid, because even if we manage to create everything else in time, without a reliable vehicle, we won't be able to implement our plans. In short, we'll need to do everything quickly and efficiently, and it's like trying to split a log with a rock. It'll take ages. Meanwhile, just take an axe and do it faster. That's why the idea of sending a nuclear bomb to an asteroid seems much more feasible. Of course, it'll be necessary to develop a new type of bomb that'll work properly in microgravity, and its explosion blast wave will have to be strong enough to break the asteroid apart. But that's still much easier than launching a fleet of spaceships equipped with lasers or nets. And it's definitely easier than coming up with a new material that'll withstand the impact of meteorites. Will humanity be able to stop a planet-killing asteroid? Most likely no. Will you survive the collision? Most likely no. Does that mean we should just give up? No. There's no point in sitting idly by and waiting for the end of the world. Instead, we better get to work. And if you want to be involved in this process, subscribe to the channel. And now, see you later.